Hello students, let us discuss the chemical reactions of group 15 elements. In this video, we are going to discuss the reaction with hydrogen. The element of group 15 is represented here E. With reaction with hydrogen, it gives rise to EH3. EH3, which is called as hydrides. So group 15 element with hydrogen forms hydride, which is generally represented as EH3. Now here E can be nitrogen, phosphorus, arsenic, antimony, bismuth. So when we make the structure, we can make the compound for these elements in this way. So if E is nitrogen, then it is NH3. If E is phosphorus, it is PH3. If E is arsenic, it is ASH3. Like this, SBH3, BiH3. So these are the hydrides of group 15 elements. Let us discuss the characteristics of hydrides of group 15 elements. First of all, let us discuss the structure. All these hydrides are covalent in nature and have pyramidal structure. Like this. So each are sp3 hybridized here. The central atom is sp3 hybridized. From this, 4 hybrid orbital, 3 hybrid orbitals are shared with the 3 hydrogen and there is one lone pair. So it have tetrahedral geometry. Let us talk about bond angle. When we compare the bond angle in these, that is 107.8 degree here, 93.6 degree in the case of PH3 and so on. So when we compare the bond angle, it shows that there is a decrease in the bond angle. From here to here, there is a decrease in the bond angle. Because in all these hydrides, the central atom is surrounded by 4 electron pairs, that is 3 bond pairs and 1 lone pair. As we move down the group from nitrogen to bismuth, the size of the atoms that is go on increasing and its electronegativity decreases. So the position of bond pair shift more and more away from the central atom, moving from NH3 to BiH3. Because being the smaller size of nitrogen, these bond pair are closer. So because they are closer, they will repel each other. So this repulsion decreases down the group because the size is increasing down the group. So the bond pair repulsion will be decreases. So because of this reason, we can say that the bond angle decreases down the group in the case of hydrides of group 15 elements. Let us discuss basic strength. All hydrides of group 15 have one lone pair. Like, let us take the case of ammonia. It have one lone pair. Because of the lone pair, it have a greater tendency to donate lone pair to the electron deficient species, which is called as Lewis acid. So here the hydride of nitrogen act as a Lewis base. So these hydrides being having electron pair, that is lone pair, it have a tendency to donate the lone pair. Therefore, it has Lewis bases. Let us compare the basic strength of these hydrides. Let us take the case of NH3 and PH3. Both have lone pair. That means both can donate a lone pair. But which one donate the lone pair easily, that is more basic. Let us compare these two, which is more basic here. Because when you compare the size of nitrogen with phosphorus, nitrogen is smaller in size and have high electronegativity. So because of this reason, because of the smaller size, the lone pair are more concentrated to a small region and the electron density on it is maximum. Therefore, its electron releasing tendency is maximum. But in the case of phosphorus, because being the size of phosphorus greater, therefore its electron releasing tendency is lesser in compared to the case of nitrogen. So what we can say that when we move from top to bottom, the basic strength decreases because the size of the element is increasing. Therefore, the electron releasing tendency, that means the tendency to donate lone pair, is decreases. Therefore, the basic strength decreases. Next, thermal stability. When we take the case of NH3 and pH3, because the size of nitrogen is smaller, so the bond length will be smaller. So it is difficult to break this bond. But in the case of pH3, the size of P is greater, so the bond length is greater, so it is easy to break the bond. So we can say that it is less stable and this one is more stable. So what we can say that the thermal stability decreases down the group because the size of the atom is increasing, therefore the bond length is increases. When the bond length increases, the bond strength decreases. So because of this reason, we can say that thermal stability decreases. Next, reducing character. Reducing character increases top to bottom because just now we have discussed when the size of the atom is increasing, that is central atom, the bond length is increasing. When the bond length is increasing, we can say that it is easy to break. And when it is easy to break, it gives H easily. So because of this reason, we can say that they have greater reducing character. That is, increases from top to bottom. When we compare the boiling point, the values of boiling point which is given here, that is, here the values are given. So this shows that the boiling point is decreasing top to bottom for these. When we compare the bond length, you can see here bond length is increases because the size of the central atom increases. So we can say that bond length increases top to bottom. So when the bond length increases, then it is easy to break the bond. Therefore, we can say that the bond enthalpy decreases. When we are comparing the boiling point, it is clear that ammonia shows a greater boiling point because it have a tendency to form intermolecular hydrogen bond. But the other members does not form hydrogen bond. So because of this reason, ammonia have greater boiling point. So let us summarize these topics, that is hydrides of group 15. The bond angle decreases down the group, basic strength decreases down the group, thermal stability decreases. Since the thermal stability decreases, its reducing character increases. The bond length is increasing because the size of the central atom is increasing. Therefore, bond length is increasing. So, greater the bond length, easy to break. That means bond dissociation enthalpy decreases. So, these are the summary of the hydrides of group 15, in which we have discussed the bond angle, bond strength, thermal stability, reducing character, bond length, bond dissociation enthalpy. These are the quite important topic. Usually in the exam, getting question based on this. So this is all about this video. Have a nice day.